Hello, this is a tutorial about how to use the debugger GNU Debugger GDB. This is a program part of the GNU build tools. It can debug programs written in the C programming language, C++ programming language, and other programming languages which are part of the GNU compiler collection, GCC. I am going to run it on Linux, Ubuntu 24.10. I am going to follow the tutorial from the KD community. I searched on Google KD Wiki GDB. This is the wiki page that we're interested in. At the end, we have an example. So let's try to run this example in a terminal. Let's make sure that we have the application command line program GDB. So it's installed on my computer. This is the tutorial. Let's run it in the directory. So what it does, it creates a source code CPP file named sieve.cpp. This is the sieve of Eratosthenes. So let's run this part. So it created the file sieve.cpp, which looks like this. Let's try to understand what the application does. So it's a C++ programming language source code file. It contains one function and the entry point, which in the C programming language is the main function, returns an exit status, doesn't take any parameters, and computes the prime numbers which are smaller than or equal to 30. This is the function that both computes the prime numbers and then prints them. In here it prints them, in here it computes them. The prime numbers are stored in an array of type std vector from this include file. It says so the index is the numbers from 0 to 30, and then the value in the array is a boolean which says true if the number is prime. And here we can see if prime at the index p, then it will write out the value because the number is prime. Okay, let's continue. We have a C++ source code file. We need to compile this file and generate a Linux executable command line application. So the command line is G++. I'm using the GNU compiler collection GCC. This is the C++ compiler from that collection. I need to specify -g because I want the debug symbols to be present in the generated command line executable, which is going to be named sieve. The only C++ translation unit and source code file is sieve.cpp, and -o says that sieve is going to be the name of the generated executable. So there's two files in the current directory, an executable. We can see that it's executable by the xchmod bit. It's also colored differently. And then there's the source code file. In order to run this executable, we need to use a relative path or an absolute path. So it does what we expect, and the program is correct, doesn't contain any bug, any crash, anything. Okay, let's look a bit at the documentation for GDB. There's a man page. GDB has two parts. One, a command line specification, which allows you to start the debugger. So you can specify the process ID to which it needs to connect. You can specify a core dump file and it will try to use that. Or you can specify the program to start, or you can specify 0 parameters, and then once the GDB starts, you will be taken to a REPL, which is a shell where you enter commands. Once you press enter, the command will be executed. This is the way you start the program without any arguments. This is the way you connect to a process ID. Okay, and then as in any debugger, you have the possibility of starting the debugger, stopping the debugger, starting the debugger until the main entry point, which in our case is going to be probably line 24 or 25, so inside the main function. You can specify where to put breakpoints. For instance, you can say put a breakpoint at line 27, this part. You can specify arguments for the executable that will be started. In our case, Sieve doesn't expect any argument. We could, for instance, make the value n not be hard-coded to the literal integer value 30, but make the value of n be sent to the program via the main arguments, so via the command line parameters. You can print any expression. For instance, you can print the value of n. You can continue and it will run until the first breakpoint. You can step one source code line, so for instance from line 25 to line 26. You can edit the source code file. It will open in a temporary VI text editor, text user interface editor. List lists the source code at the current point if you offer the parameter to list dot. So if you go list space dot, it will print the current line. Let's say it's line 25, and then 5 lines above, 4 lines below, so 10 lines in total. Step is step into. For instance, if you're on line 27, instead of advancing to line 28, it will advance to line 5. Help, without any parameters, shows the help of GDB. With a parameter, it will show help about that category. We will see immediately. When you run just help, it will list all of the possible categories. You can exit from GDB. You should read the entire manual at least once. Okay. Next up, we're going to run GDB and tell it to start a subprocess named Sieve from the current directory. Okay, so it prepared the executable Sieve for being started. It did not actually start it yet. Let's look a bit at the help as the man page suggested. So help says that there's these categories for help. There's help for running. So that's step over, step into, step out, continue. Then there's help for breakpoints, set breakpoint, delete breakpoint, set breakpoint at all functions named like a given string, set breakpoints at a regular expression, set watches. Okay, examining the stack, it will have support for showing the, for instance, if we're on line 6 with the execution, it will say that the current core stack is on the top. There's sieve of Eratosthenes, and then at the bottom of the stack there's int main. Then as a user help, there's text user interface, which for instance can show you both this thing, the REPL, the GDB shell, and the source code file with the current position and some breakpoints at the same time. Okay, let's look a bit at running. So help, running. So continue runs to the next breakpoint. There's support for advancing backwards, so from line 26 to line 25. This thing doesn't really work for me. Then there's step over, which is next, or n, which goes, for instance, from line 25 to line 26. There's a next instruction, which goes through the assembler. GDB also has a functionality where it can show you the source code in a window, the disassembly, so the assembler in a window, and then the REPL in a window, also using the TUI text user interface mode. Run is how you start a program if you don't care about breakpoints. If you just want the program to run, for instance, until the program stops and finishes, or until the program crashes. You can use the command start, which will run the program to be debugged until it hits the main entry point, so until probably line 24 in this case. Start, really important. Step, or S, is step into. So if you're on line 27, it will advance to line 5. Finish is exiting from the current function. So step out. So if you're, for instance, on line 11, finish will advance to line 28. There's a built-in paginator. You can press enter to go to the next page. You can press Q to exit, or C to continue without paging, which will not use the paginator. I pressed C and then enter. Okay, so we're going to just run the application, or run. This is support for debug info D, which is a daemon which is part of GDB, which allows you to see and debug, so to see debug symbols for files which exist in my Linux operating system. So I'm on Ubuntu 24.10. there are many shared libraries.so files, for instance, in the /usr/lib directory. All of those .so files are Linux binary ELF files, but they have been stripped, don't contain debug symbols. If we enable debug info D, then the debug symbol files for the .so files which are part of my Linux operating system will be downloaded on the fly as needed and made available inside the GDB, such that the debug symbols for those SO files are available. I actually do not want this. I do not want to step into, I know, the OpenSSL library, the GNU C library, etc. So I'm going to keep the default. The default is N. So I'm going to press enter. No debug info D for me. So what it did, it has loaded the program, including all of the SO shared library files. It has started the process, and then the process did whatever it did when we ran the command line /sieve. So it wrote this thing, which is this thing, and then it wrote the prime numbers, which is this thing, and then it printed a new line, which is advancing from this position to this position. So inferior one means the process that has been started by GDB. This was the process ID 815219, exited normally in the sense that the exit status of the process was 0, which means success. Okay, so in here it says that if you want debug info D, then you can choose no here. So we saw that run just runs the process. We don't have any breakpoints. It will not stop anywhere, but we actually want the debugger to stop somewhere such that we can exercise many other GDB command lines. So we're not going to start using run, which runs to the next breakpoint. We're going to start using start command line from GDB, which runs until it enters the main entry point. Okay, and now the execution of the so the same thing, the executable sieve has been loaded, started, and it says temporary breakpoint 1 on main at line 25 of the file sieve.cpp. So it did something similar to creating a breakpoint in here and then running run. So very advantageous. You sometimes don't know exactly where the main entry point is, in which CPP file. Maybe it's hidden in a huge Git repository of a C++ source code project. So start is really good at digging up the main function. So we're on line 25. We can advance. So step over. The instruction for that is next. So now it advanced from line 25 to line 26. The application sieve is paused in the debugger. So next or N. Okay, we're going to press N now instead of next and see that it's the exact same thing. Advances to line 27. N, line 28. There's history, so the up arrow key will write at the prompt the previous command that we have run. In our case, it's n. So up arrow key, enter. We're on line 30, and now the process will finish. Okay, I'm not sure what this thing is. libc start call me. So this is probably part of the GNU C library. And again, the process CIF has finished, successfully exit status 0, a different process ID than previously. So previously the process ID ended with 219, now it ended with 486. We're at this line. Okay, let's start again. It stopped on line 25, which is this one. And to the command n, we can give parameters. Let's see if n has help. Yes, it does. So you could write help n or help next. It's going to list all of the help that's available for this command. There's an optional parameter, which is this n. Steps into, and next steps over. So step into means enter into the, if you're at a call site, enter the callee, so enter the function. Whereas n means if you're at a call site, so on line 27, advance to the next line on the current function or frame. Okay, so this is what we want to exercise. We want to go n and as parameter provide 2. So n means next and then 2. What it does, it runs the command, which is n, 2 times. So it was on line 25. It ran n once, line 26, run n a second time, and now it's the debugger GDB is paused on line 27. Okay, let's look at the source code. While the debugger is paused at a line, you can do two things. You can edit. Again, it will open a temporary VI text user interface text editor, and you can edit the source code there. Or you can list. The command line parameter for the command list that I use is dot, which means there's the point of execution in current frame. So that's the line where the debugger is paused. In our case, that's line 27. That's what I'm interested in. I want to see 10 lines around or centered at line 27. Lists 10 more lines. If you don't provide any parameter, the return of list, so list without any parameters, is not what you really expect. So list dot, always use list dot instead of just list. Okay, so we run list dot. The current line is 27, and we see lines 1, 2, 3, 4, 5 above, and 1, 2, 3, 4 below. So 4 below the current line and then 5 above, that's exactly 10 lines. 10 lines are listed around that line. Okay. We have run help list. You can change the list size if you want more than 10 lines to be displayed, which I do not want. It's enough for me. So the command would be set space list size 20. This makes also executions of the GDB command list, not list the default number of lines, which is 10, but list 20. Since we're at line 27, let's exercise the GDB command step. And now from line 27, instead of advancing to line 28, it jumped to line 5, which is the open curly brace of the free function, C++ function sieve of Eratosthenes, which receives a parameter of type integer named n. We can list. So again, the listing is centered to line 5, which is the line where GDB is currently paused. Okay, if you don't remember how to exit a function, you could remember that there's help, then there's the possibility of running help running. And in here you will have to search for how to exit the current frame or the current function. Execute until selected stuck frame returns. Finish, or you could use fin. I'm going to press C to continue, and then finish. Okay, and it says that it's back to the main function. And it advanced to line 28. So it was on line 27, and now we're on line 28 post. Okay, similar to other GNU style REPLs, read, eval, print loops, such as, I know, the GNU bash command line shell. There's auto-completion. For instance, you can run like this. So I wrote just text and then pressed the tab key on my keyboard once, and it did auto-completion. And press enter. So this is if you want to have more than just the REPL visible. So REPL is just one of the possibilities, the default possibility when you are inside the GDB. You can see which the REPL is by looking at the prompt, which is parentheses, GDB parentheses, and then space. But you can also see more than this window. You can see the this is called the CMD window. You can also see the SRC window, which is the source code window. There's also the ASM window, which is the assembler, so the disassembly or the instructions that are being actually run on the CPU. Let's start TUI. The command line is this one, TUI enable. You exit TUI mode with TUI disable. So these things in blue are GDB commands. This is how it looks like. We now have two windows. This thing and above is the SRC window. this thing, and below is the CMD window. How do we know that? Because we have this command info win. So says that actually 3 windows are visible. There's CMD, this one, which does not have focus, SRC, which is this one, which does have focus, and we can see that because the window decoration has this green background, back color. And then there's status, which is probably this line. Okay. So we've exited the main function. Let's run some commands in here. For instance, n. We can see the standard output. Pressing Ctrl L, similar to bash, clears. So we saw the normal GDB things, and then overlaid on top there was some random text, which is part of the standard output of the executable. When you see garbled text or GDB not looking perfect, then this is one way to fix it, Ctrl L, which actually will refresh all of the GDB output. Okay, this time we can see that the program is paused and the current line is 29. We can see that by this greater than sign and this white background. Previously, when the SRC window was not visible, after you run the command line next or n in GDB, it will say something. It will say, now you're on line 29, return 0. Now there's no need for GDB to write that thing to say that you're on line 29, which has the content return 0, because you can see that in the above window, the SRC window. Now we're on line 30. And one more, we will be out. Let's run everything from start. We can see that now it's on line 25. We're going to run twice. Step over, so N2. And then step into. And now we have 2 greater than signs. And some interesting things in here. Sivo Eratosthenes 5, I know. This looks like a garbled output from GDB. So we press Ctrl L. And now there's only one greater than sign. On line 5, the one from line, I don't know, 27 disappeared, which was incorrect. The SRC window is now a bit taller. The status window is now one line below. So whenever you think that something's not great on what you see on inside GDB, go Ctrl L. It doesn't hurt at all. Okay, let's run what the tutorial says. So we're in here, info win. So a problem when we enter text user interface mode is that the focused window is the SRC window, which means that pressing the up arrow key doesn't do what I expect, which is to go through the history inside the GDB CMD window. Instead, because the focus is on the SRC, not on the CMD window, it will scroll the source code like this. So if I press the up arrow key, so I click in here where it says the GDB prompt, but still the focus is somewhere else. So if I press the up arrow key, it will execute the binding for the up arrow key for the SRC window, which is scroll up one line. I do not want this. What I want is that the focus always be on the CMD window, not on the SRC window. Okay, so we want to move the focus from SRC from here to CMD to here. The command is TUI focus. We can see that by going to the help, text, autocomplete, press enter, and this is the command line TUI focus or just focus or FS. Without any parameters, it will go to the previous next window. Okay, does not matter. We're going to provide parameter. Let's see if help works. UI focus, window name, next or prev. I have used InfoWin to see the names. So I want the command line TUI focus to CMD window. It says that the focus has been changed from here to here. We can see that because now the window decoration of cif.cpp doesn't have the green background. And if we press the up arrow key, it will go through the history. And if we run InfoWin, it will say that the window CMD now has focus. Okay, let's see how we set breakpoints to a source code line. This is the syntax break 11. Break or just B, and you can tell it a location. You can give it a file name. You can give it a function name. You can give it interesting things like address locations. You can say which function from which file. And in case nothing works, then there's regular expression support. Okay, so we go break. We're not specifying any command line, any source code file, so it's clear that the source code file is cif.cpp, and we just specify 11. In this case, 11 will be interpreted as the line number in the current source code file. So it should put a breakpoint in here at prime of this line 11, where we set false to prime of I. We can see in the text user interface GDB Windows SRC. At line 11, there's a B+. Okay. We have where are we currently? So focus SRC. I need to press the left arrow key once, such that I can see the source code. And now I'm going to focus on the CMD again. Okay, so the execution of the sieve subprocess is paused on line 5. We want to run line 6, 7, 8, 9, 10 until it reaches line 11. If it reaches line 11. If these ifs do not allow, if line 11 is never executed, then the execution will go to the end of sieve process. So the command is continue. Let's look at the help. Continue n, which means that if you have multiple breakpoints, the command line continue will be executed more than once if you provide a value, an integer value which is greater than 1 as parameter for the GDB command continue. Okay, we can now see in the SRC window that there's a B lowercase b plus, so that's the breakpoint. Then there's the greater than sign, which means that the execution of the sieve subprocess is currently paused on line 11. So there's a ton of action on line 11. A breakpoint is being set and the execution is paused at the same line. Says help. You can see that you can look for help on breakpoints. You can put breakpoints like we did by specifying a file name, a source code line number, a function name, address, a function inside of a file, etc. There's support for catching, automatically catching in programming languages that have something similar to try catch or throw or except, such as C++, Pascal, etc. In order to remove a breakpoint, the command line is clear. So in our case, we want to remove the breakpoint on line 11. We use clear. What parameter you must specify for clear? Again, you can look inside of the help. So help space clear. You can create conditional breakpoints. So that's break and then if on the same command line. You can delete all breakpoints, delete breakpoints. Enable, disable all breakpoints. Things that you know from a editor for source code file that has debugger support. For instance, an integrated development environment such as, I know, Microsoft Visual Studio, Visual Studio Code, Eclipse, etc. Break is regular expression that you specify where to break. And then there's watch points. So watch and then you provide an expression. A watch point is actually a breakpoint. Okay. We want to list all of the breakpoints. info or I shows information about the program being debugged, and we're interested into bookmarks. So integrated development environments usually have a tool window with the list of all of the breakpoints that are currently set inside of the debugger. For instance, you can disable all of the breakpoints. There's a button for that. You can delete all of the breakpoints. There's a button for that. You can delete one individual breakpoint. There's a button for that. So we want info breakpoints or info B. A ton of information. Info B says that we have just one breakpoint, the breakpoint or in here. So in the column num it says 4. That's on sieve of Eratosthenes, sieve.cpp line 11. This one. And then there's statistics. It says that the breakpoint has been hit once. It will be hit many times because it's inside a double 4, so 4 inside the 4. So we did info breakpoints. Also inside info, you can see that there's support for listing all of the local variables. So in our case, that's there's this vector named prime. Then there's the iterator variables p and I. And then there's the n, which is the argument to the current function sieve of Eratosthenes. So let's see that. And it lists I, p, and prime. And it lists these very human readably. I and p are just C++ plain type integer. And prime is also a built-in C++ type, a type from the C++ standard library, which is std vector of bool. And for prime, it says the correct type, also says the length, and all of the values. So for now, all of the numbers, 31 of them are set as being prime. And on line 11, some of these values inside of the vector will be changed from true to false, because that number is definitely not a prime number. Okay, we can print just the name of the variable. We can run some evaluations. So the value of I is 4, and the prime of I is prime of 4, which is true, which is this one, 0, 1, 2, 3, 4, this one. And we can also execute C++ source code, C++ methods in this case. So prime is an std vector of type bool, has the methods front and back, and we're executing the method back on the prime variable. And you can do all sorts of interesting things. If you have pointers, we can dereference them. And okay, let's look at the backtrace. Not info, but help. Alt backspace works as expected. in a readline text user interface application, which in this case deletes the previous word. Control U works as expected, deletes the entire line. So help backtrace. Prints the backtrace of all stack frames. There's a count parameter. Let's exit with the letter Q. Okay, so backtrace or T says that we're on line 11. On the top, the newest function that has been entered is at the top of the stack, and it's Sivof Eratosthenes line 11. And further down in the stack, at the bottom of the stack, there's the first function that we entered, which is main, and the current position inside of the function main that we're right now is line 27. We're at line 27, but at line 11. Okay. For this prime. It shows the type. If it's a C++ object, it will just say object. And there's also p-type. This one, if it's a object, it will try to find the member variables, so the fields of the type object, and it will print them. Okay, let's put a watch. This probably puts a breakpoint whenever the value of prime of I changes. It says watch point 5 prime. We can look at the breakpoints, and now we have two breakpoints. One is of type breakpoint with the index 5, with index 4, and index 5 there's a breakpoint of type watch point with the expression prime of I. We did info breakpoints, info B, the same thing. We can remove breakpoints. Let's remove the breakpoint, this one, 4. Help clear. Line spec explicit or address location. We have a line spec. Clear. Let's see if just 11 works. Yes, it knows. Otherwise, you can specify like this the source code file name and then colon the line number. Now, if you run info breakpoints, it says that there's just one breakpoint of type watch point with index 5. Let's run continue a number of times such that we can see how it stops on line 11 every time, even though there's no breakpoint on line 11, there's just one watch point. This thing, I don't exactly know what it is, but probably it's because the way I have put the watch point, maybe just in here, the mutation takes place. So this is operator equal bool or bit vector. And now it stopped on line 11. Back into the C++ standard library from GNU. Back on line 10. Okay. Let's run Ctrl D to quit. Says that GDB can exit, but it still has sub-processes which are running, in this case sieve. It shows the process ID and says that that process will be killed because it's a child process, and when you kill the parent process, the whole process tree of that process will be killed, which is okay. Yes. You can enter straight into text user interface mode. Let's do it like this. So GDB. Silent is to not print the banners, the initial lines. Enters text user interface mode. Focus is on the SRC window. Let's move focus back to the CMD window. And then that's it. We go start. No debug info D, press enter. Next a number of times. Control D. Yes, start again. Next, start. Next, next, enter with step. Next. So just press the up arrow key and then. Okay, so additional, in here we can also see that the output is garbage, so Control L. The next steps to study is how to work the call stack, how to exit one level up, so that's finish. How to list the backtrace, how to list all of the threads, how to evaluate variables, so that would be the print command, but advanced usage of that. If you're using exceptions, how to break on exceptions. If you have a crash, how to run until the crash, so that would be run GDB with command line parameter, the name of the executable that crashes, and then you're going to run the command line run, which will pause the execution when the sieve process or whatever the subprocess of GDB will want to crash. Then you can create from inside the GDB, you can create mini dumps or core dumps. That's a file that contains the current status of execution of the subprocess. And then you can start GDB providing as parameter that core dump file, which allows you to inspect the status of that point in time of a running process. So you have a process, you're attaching to it, for instance, you break it, so you pause the debugger, and then you save all of the state of the process to a core file, and then maybe a number of days later, you are curious what exactly did happen inside of that process. And that time you're starting GDB with command line parameter provided the name of the dump file, and in there you can inspect the threads, the call stacks, the local variables. You can inspect additional variables and members of objects, etc. So this is it. This is how an introduction on how to start using GDB, the GNU Debugger. It's a very important tool. It's a must-know for programmers that use the Linux operating system or use G++ or the GNU compiler collection. If you're doing DevOps, if you're using Linux containers, if you're administering Linux machines remotely via SSH, this is part of the minimal toolset at your disposal. If you have a crash, what do you do? If you have a process that enters an infinite loop and consumes all of the CPU, what do you do? So this is GDB is a way of replying to those answers. Thank you.